Evening, students. It's Mr. Rich, another Sunday night math Q&A, and I've got about 4 or 5 students here live with us tonight. If you have any questions you want me to address, you can put them into the chat or you can send them to me in email at askmrrich@gmail.com. I don't see any messages that have come through with questions. So hopefully some of you will send in some questions and we can work on those. Just click on the chat and you can do it. Well, looking at the students that are here, we've got a couple calculus and then maybe some pre-calculus students. So I'm waiting for questions to come in. I see one for Missy. I'm going to take a look at that one. Let's take a look. I'm going to look at the chat there. I'm going to copy and paste that. I think this will work. And I will share my screen. So while I'm working this problem, if you've got a question, especially you pre-calc students, I know that you've got a test coming up this week over 2.1 to 2.5, and we will get to that. At the end of this, I'm going to go over my top tips for improving your grade in the second quarter here. Here is the question, and this is an AP calculus question. A particle moves along the x-axis so that at time t is greater than or equal to 0, its position is given by x, left parentheses, t, right parentheses, equals. Okay, so let me see if I can. All right. So we have a position function, s of t, 3t cubed, minus 27, minus 27t. Okay, plus 81. I think that's right. Yeah, I think so. Okay, determine all intervals when the acceleration of the particle is positive. All right, did I get that right, Issy? It looks like they're giving us this position function, and then they want us to find out when the acceleration of the particle is going to be a positive value. Would that be true? It's 81t. I thought it was 27. Oh, 27t squared. Got it. Thank you. That makes so much sense. How's that look? Okay, good. So this is a position function, and we need to get the acceleration function. So those of you that are in AP Precalc, what you're going to be doing is learning how to take derivatives of functions. And so what I'm going to do is I'm going to take the first derivative of this function using something called the power rule of derivatives. So we call that first derivative s prime of t, which is also known as the velocity function. If this is the position function that gives me the position of the particle at any time t, the derivative is the velocity. So this is going to be 9t squared minus 54t plus 81. That gives me the velocity. Well, we need to get to the acceleration function, so I'm going to take the derivative of the velocity. So I will take v prime t, the derivative of velocity. That's going to be 18t minus 54. Now, this is of interest to those of you that are in pre-calc. This is the acceleration function. The question here is, when is the acceleration of the particle positive? This is just asking me, when is this function going to be positive? And you know that functions are positive when they are above the x-axis, or in this case, the t-axis. So you can't know when a function is going to be above or below the x-axis until you find out when it is at the x-axis, because when it touches the x-axis, that's the time, or that's the place on the x-axis where it might change from being underneath to being above. So what I'm going to do is I'm going to set this thing equal to 0. And when I do, I'm going to get the x-intercept, right? So 18t is equal to 54. Is that t equals 3? I think it is. Right, t equals 3. So this acceleration function crosses the horizontal axis t at 3. And what we do typically to find out when the function is either positive or negative is, this is where the function is 0. So we pick a test point at, in this case, t equals 2 would be just to the left of 3. I'll pick t equals 4 to just be the right. And let's evaluate the function's sign. Well, when t is 2, it looks like the acceleration's negative. It's going to be positive to the right of 4, right? If t equals 4, you plug it in here, you are going to get a positive value. Now, are there any limits to this? It just says that it's moving so that time is greater than or equal to 0. So that means then that my answer here is he would be, and my answer would be from 3 to infinity is where acceleration is going to be positive. Okay. All right. And then Taylor says test in Calc AB 4.1 and 4.2. Don't have specific questions. You're able to yeah, well, sure. We can do some review on that. Okay. All right, Izzy. I hope I answered the right question. I think I did. Well, pre-calc students, where's the questions? Don't see any. I'm going to do a little bit of pre-calc and I'll show you what I'm going to cover. And then I'll do a little bit on the calc side there, Taylor. So hang tight. Here's what I want to go over for the pre-calc students. I want to talk about how you find for an exponential function that has had a vertical shift to it and without a calculator. And I think I'm going to use this one here. Yeah, I've worked this one with several students, I think, in one-on-one sessions, but I'm going to cover it here. So below is a table. It tells us for an exponential function that's in the form of a times b to the x plus k. So there's some sort of vertical shift to this. And they give us the some x and y values. But one of the things that you have to find with an exponential function is you got to find what the common ratio is. That is, what's the base of the exponent going to be? That's the very first thing I have to find if they've given me a table of values. And one of the things that throws students off on this problem is if you try to find the common multiplier, you say, okay, 6 times 2 is 12. But wait a minute, 36 divided by 12 is 3. There's a multiplier of 3, which might lead you to believe, wait a minute, what's the common multiplier here for this exponential? What is my base? Well, you don't see it in the output values because of the fact that there was this vertical shift involved. But you do see the common multiplier when you look at the first level differences. We got to look at the first differences. So if you take a look at the differences here, this is an increase in 6. This is an increase 24. That is an increase in 96, I believe. And then let's see what this is. 516 minus 132. Oh, there we go. 516 minus 132. So that's 384. And here's where the common multiplier or the base of the exponent shows up, because now you do have a common ratio. 24 over 6, 96 over 24, 384 over 96 is 4. So I just discovered what b is right here. So what I'm going to do is I'm going to write this function as f of x equals a times b 4, because we now know that that's 4 to the x plus k. And now the only thing that we need are the constants a and k. So we're going to stick the first point that we know it has to be a solution to this. We're going to stick that into the function. So we get 6 is equal to a times 4 to the 0, which is 1, plus k. So that gives us one linear equation. And if I'm going to find out what a and k are, I need a second equation. So I will move over and stick this point into this equation. That gives me 12 is equal to a times 4 to the 1 plus k. So this is basically a system of equations in two variables that you're going to solve for a and k. Well, you could stack these underneath each other and do an elimination. This is pretty straightforward to do subtraction here. 12 minus 6, 4a minus a, k minus k is 0. Now I know that a is 2. Is that right? That doesn't seem like that was the answer that we got. Maybe I'm thinking of a different problem. So a is 2, and then k is 4, according to this. No, yeah, k would be 4. So then I would know what my function is. F of x is equal to 2 times 4 raised to the x plus 4. I think that's right. Let's check that and see. I'm going to plug in 4 there. So, well, I know what 4 to the 4 is, right? So 4 to the 4th is 256 times 2, 512 plus 4, 516. Yeah, so it checks. So that's how we do that. The other thing that you have to be able to do is you do have to be able to do an exponential regression on your TI-84. That's lesson 2.5b in the pre-calc. You should have covered this in class, but it says here, use an exponential regression to model these data. Now, I'm not going to go through this whole problem, but I am going to go through the process that you would use. You have to put this data, the X value and the Y value, not Y1 and Y2, but list 1 and list 2 of your TI-84. You do that by doing stat edit, and then you can put in for list 1, 1, 2, 3, 4, 5, and then put in the corresponding Y values for the det here in list 2. Once you have that in, you do second function quit. And then the command that you need to run to actually do the exponential regression is you're going to do stat calc, and you're going to run 0 in the stat calc menu. It is going to ask for the X list and Y list, which is L1 and L2. Your calculator will probably default to L1 and L2. You leave the frequency list blank. You store the regression equation right here. So you definitely want to, it even tells you to do it, but it shouldn't have to ask you to do this. Your teacher should show you that once it creates this regression equation, you want the calculator to stick it into Y1 of your equation editor on the calculator. So how do I stick a Y1 there to tell it to store the regression equation? You do alpha trace. I know you would never know that that's where this menu is, but right, someone has to coach you and show you where this is. Alpha trace, you get to pick what function to blow into that field. It's a Y1. Then you go down and calculate. Now, those aren't the right answers because I did not put that data in. This is for a different set of data. But what this does is it tells you what the regression equation is. It tells you that it's y equals a times b raised to the x. There's your a, there's your b. You would round those coefficients to 3 decimals and create the equation, and that becomes your answer right here. Now it's super simple. Here for part B, it says, use the model that's stored in your calculator to predict how much Mr. Kelly will owe Mr. Sullivan in year 7. So if you are coming out to the 7th year, you want to use the equation that the calculator just generated to evaluate it when X is 7. Well, you go back to your home screen, second function quit. I'm now on my calculation home screen here. And you go back and do alpha trace again and call up Y1, hit parentheses, and then put in whatever value of X you want to evaluate in the model, right? So if I wanted to do year 7, I would say, hey, pass the value of 7 and return the value. Now that's not the right answer to this because the equation that it's using is not the one for this particular problem. But if I show you, if I hit Y1 right here, up here in Y1, this is the exponential equation all the way out to about 12 decimal places, right? So there's the base of the exponent, 1.28, blah, 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 raised to the x power. So when you are back at the home screen and you do Y1 of 7, it's passing 7 for x, plugging it in, and then it's returning the answer to you. All right. And then I'm going to show you how to do part C. This says on part C, if Mr. Kelly loses every year from now on and refuses to pay Mr. Sullivan, in what year will Sullivan be owed 5,000? So what they're wanting you to do is stick 5,000 into this function. I'm going to make up some numbers. Suppose it was 4 times 3 to the x. They're wanting you to solve this equation, 5,000. So you're sticking 5,000 in for the y variable, and then you're solving for x. Now you can do it algebraically, but there's an easy way to do this on the TI-84. And what you're going to do is you're going to graph the line y equals 5,000 and see where it intersects this function. So this function, suppose it is, it looks like it's exponential growth. So it would look, if you envision this, it's an exponential growth function like this. And we're coming up here and we're going to graph a horizontal line at 5,000 and see where it intersects. And then this value would be the year in which Sullivan will be owed $5,000. Okay. And so I would come up here, y equals, and I would graph another line, y equals 5,000. I would see where they cross each other. All right, now the trick there is you got to set your window, or else you're not going to see both of the graphs. So you got to make sure that your window is scaled properly. Okay, hopefully though, you've got time to go over that in class before the test. All right, let's see what else we got here. Okay, I'm going to do a quick question for Edson here. Let's see if I can do this. I think this will work. Looks like it comes from Delta Math right here. Well, what I'm going to do, it looks like they want us to get this into a singular fractional exponent. So I'm going to first, underneath this radical, use my rules of exponents to multiply that. That would be z to the 10th power, adding the exponents. I'm now going to, Edson, move that z to the 10th up into the numerator, and it would become z to the minus 10. And it's the 8th root of z to the minus 10. Well, what I'm going to do now is I'm going to use this property or this rule of exponents that says that if you have x to the a over b, it is the b root of x to the a. So when I convert this to a fractional exponent, that's my numerator, that's my denominator. And so this will become z to the negative 10 over 8, which would be z to the negative 5 over 4. So the answer that I'm liking is that one right there. And now I'm looking for my chat. Okay. All right. Let's do a little bit of practice on Calc 4142. All right, let's do some problems here. You see, it looks like you sent me a Delta Math something or other, but it's not coming through. I think you might have to take a screenshot of it. Here's a question involving some trig, right? So this gives you the position of a particle. It's x of t. Find the acceleration at t equals 0. Well, if they give me a position function, to get to the acceleration, I have to take the second derivative. The first derivative is the velocity function. I have to use the chain rule to take the derivative of this, but the cosine of something is negative sine of that something, but times the derivative of the something. So this becomes negative 3 sine 3t. This would be negative 4 cosine of 4t. I got to take the second derivative though, because that's just velocity. I got to get to the acceleration. This is going to be negative 9 cosine 3t by using the chain rule again. Derivative of cosine is a negative sign, so this is going to go back to positive 16 sine t. Now we can evaluate this second derivative, which is the acceleration function. We can evaluate it at 0. That's 0. Sine of 0 is 0. This would be a negative 9, right? Cosine of 0 is 1, so negative 9. And that's our answer right there. All right, let's take a look at this one. Now I see that one. You see, there it comes. Okay, we'll move that over here if we can. Okay, this one says, when is the object speeding up? So you have to be careful with these graph problems and making sure that you pay close attention to what are you looking at? Are you looking at position, velocity, or acceleration? This is velocity, right? It tells us, but you got to make a point to like write it on there. It's velocity. When is this object speeding up? Well, the object is going to be speeding up when the acceleration and the velocity are opposite signs. So I can tell here that, right, if you take a look here at t equals 4 and split the graph right here, this is where velocity is negative because the function is below the x-axis. Over here to the right of 4, the velocity is positive because all of those values are positive. Well, what is acceleration? Acceleration is the derivative of the velocity. It's the slope of the velocity. So over here, you can see that this right here, from 3 to 4, that acceleration is positive right there, from 3 to 4, while the velocity is negative. So it is speeding up. So I kind of like that answer, but let's make sure there's not another time when it would be speeding up. I'm sorry, that's when it's slowing down. Oh boy, it's when it's speeding up. So it's speeding up when they are the same sign. That's when it's slowing down. So same sign. So never is the acceleration negative down here. Here the acceleration is 0. Here the acceleration is positive. But what happens here is since the slope is positive right here, over that stretch right there, acceleration is positive, but so is velocity positive in that same stretch. And that goes from 4 to 8. So I'm liking this answer right here. What happens between 8 and 12? Over here, velocity is positive because the function is above the t-axis, but the slope is negative. So the acceleration is opposite signs mean it is slowing down. When does it reverse direction? Well, it reverses direction at 4, because that's when the velocity changes from positive, or it changes there from negative to positive. So the velocity, it was moving left, then it got to time t equals 4, and then it started moving right. So it changed directions at 4 only. When does it attain its maximum acceleration? Well, it's going to attain the maximum acceleration when we have slope being the highest. And it looks like it'd be on that stretch from 3 to 8. That's when that is going to be the highest acceleration. And then when does the object slow down? It does slow down, but we said between 3 and 4, when the acceleration and velocity are opposite signs, but also between 8 and 12, because up there the velocity is positive, but acceleration is negative right there. All right, let's take a look at Issy's problem here, delta math. A particle moves along the x-axis so that its position is given by x of t. So unlike the previous problem, we are looking at a position problem here. Find the total distance traveled by the particle on the interval from 0 to 18. Okay, so, and is this a multiple choice problem? No. But at any rate, so this is position. So what we have to do, it is here, from here to here, the velocity is positive. So it's moving in the right direction, and it's moving from a position of -6 to 0. So it moves 6 units right there. Then its velocity, it looks like it changes directions, right? Because now after you get past this point right here, the slopes are negative, which means the velocity is negative, and it is moving from a position. I'm reading position off the y-axis. It's from 0 to 4, so it is 4. I'm only counting positive values. Total distance traveled is not with respect to positive, negative, left, right. It's just the distance that you're traveling. And then it looks like it stops here and changes direction because now the slopes are positive. Remember, slope of position is velocity, and it travels from a position of -4 up to 5. So that's another 9. I'm going to add another 9 right there. And then from here to here, it's going from 5 down to -4 again. So I'm adding another 9 distance traveled. And then from here up to here, it's going from -4 to 4. So I'm adding 8 more onto that. So it looks like 6 and 4, 10, 19, 28. I'm going with 36 as my total distance traveled there. So the secret there is making sure that since we're dealing with, you're reading these distances traveled between these time intervals, you're reading them off the y-axis and only taking the positive values. I see another message. Okay, I'm going to do another one. This is calculus. Where are my pre-calc questions? I thought I'd have pre-calc students here, like ready to ask some questions. Look here. There we go. Another question. Calculus. Particles moves along the x-axis at time t greater than or equals 0. So its position is given by that. Determine all intervals when the particle is moving to the left. Well, the particle is going to be moving to the left when the velocity is negative. This is the position. So I need to find the velocity function. I'm going to squeeze this thing. That thing's just a bit too big. All right, let's zoom in here. I'm going to get the velocity function by taking the derivative. 3t squared minus 60t minus 63. Remember, I'm trying to find, if I want to know when the particle is moving left, I got to know when the velocity is negative. I can't determine intervals over which the velocity is negative until I know when the velocity is zero. I have to know the x-intercepts or the t-intercepts here, the horizontal intercepts. So I got to set this function equal to zero. Thankfully, these things are all these coefficients are divisible by 3. So I can divide through by 3 and rewrite this as this. That makes the factoring a lot easier. Let's go with what I want here. Negative 21, positive 1. Now, I'm only considering the domain of t greater than or equal to 0. But this velocity is going to be 0 when t is negative 1. So let's draw the t-axis here. No, I'm only starting at 0. That's where my domain is. But it does cross at negative 1. And you would agree this is a parabola. And it is a parabola that opens upward. The other intercept is over here at 21. So it does look like halfway between 21 and negative 1 would be 10. So we don't really need that. But this is a parabola. It's looking something like this. So I've already answered the question. If the velocity is a parabola that crosses at negative 1 and 21, it's moving to the left starting at 0, because starting at 0, it's going to be down here at a negative value all the way up until it reaches 21. Time t equals 21. And after 21, this thing's going to turn positive. So my interval here, I think, yeah, this was this. My interval where it's moving left would be from 0 to 21. Now, the way that officially you do this, right? Let's talk about the way. If I did this because I knew it was a parabola, but what you do is you find where the critical values are, right? Where the derivative is 0, where the velocity is 0. It's right here. And what I would do is I would pick a test point. I would pick the number 1, which would be between 0 and 21, and I would pick the number 22. And what I'm interested in is what is the velocity for those two test points? And I use the factored form up here. When t is 1, x is 1, that would make this factor negative. This one would be positive. Negative times positive is negative. When t is 22, it'd be 22 minus 21, which is positive. 22 plus 1 is positive, positive. That means it's positive. So yeah, so that means that my interval where the velocity is negative is from 0 over to 21. 0 to 21. All right, let me spend a bit of time then. Let me see if I still have pre-calc people here. I got to see, maybe some people dropped off. It's just 4 of us now. 2 calculus and 1 pre-calc. Everybody else just bailed on us. All right. Well, let me remind the pre-calc students of 4 formulas that you need for your test. And this covers a lot of 2.1 to 2.3. And this is what I want to say. We studied arithmetic sequences and linear functions. They're really one and the same. Arithmetic sequences are discrete linear functions. They're dots that form a line if you were to connect the dots. But the 2 formulas that we use are nearly identical that represent the sequence and the linear function. The nth term of an arithmetic sequence is ak plus the common difference times n minus k. You supply whichever term you want in the sequence into this slot right here, as long as you put the number of the term in for k right there. And you obviously need the common difference for the sequence. That's what we call the slope. Well, linear functions, it's the same function. It's the point slope equation. Now I'm writing a modified version of the point slope. I'm moving that y minus y1, I'm moving the y1 over to the right side. It looks like this. That's how you write a linear function. And those of you that are taking calculus, you're very familiar with this. This is called the point slope form of a linear function. It's extremely useful. I need the slope and any point that happens to be on the line, x1, y1. But you notice it's the same equation as this. This is like at the x value that goes with that y value right there. The other thing that you need to know is that in 2.1 to 2.3, we dealt with geometric sequences / exponential functions. And geometric sequences are simply, they are discrete exponential functions. The nth term of a geometric sequence is written like this. You take any of the terms in the sequence, gk, times the common ratio raised to the n minus k. Or if we're talking about an exponential function, you could write it like this: y1 times the common ratio raised to the x minus x1, like that. And the only hard part maybe in geometric sequences and exponential functions is finding the value of that common ratio. Let me give you an example of what I'm talking about. Suppose I tell you that there are 2 points, 3 comma 7 and 7 comma 19. And there's an exponential function that passes through those 2 points. Give me the equation of that function. Well, a lot of students are going to struggle with this unless you know what you are doing, unless you know how to use this form of an exponential function. The easy part is I'm just going to use one of the 2 points for x1 and y1. I'm going to call that x1. I'm going to call that y1. That's going to go in, those 2 numbers are going to go in here. Not putting anything for x because that's my variable. But I do need to calculate what the common ratio would be that would make that an exponential function. And here's how we would do this. If I tell you that 3 comma 7 is one of the points, that means that when x is 3, y is 7, then there's a value at 4, there's a value at 5, there's a value at 6, and then there's a value at x equals 7, which happens to be 19. I don't know those in betweens. But one thing I do know, that as I move from 7 towards 19, I would be multiplying by the common ratio each time, times r, times r, times r. Well, how many times do I have to multiply 7 by to get to the answer of 19 at the 7th term? Well, 4 times. I don't need to draw this out. I know that 7 minus 3 is 4. So there's 4 jumps, 4 multiplications by r. So I write this equation: 7 times r 4 times has to be that 7th term at 19. I will divide by 7 and take the 4th root. R is the 4th root of 19 sevenths. So this happens to be exponential. Well, it's not, it's definitely exponential growth because I'm going from 7 to 19, but that is the common ratio right there. So I can write the function. F of x is, like I said, I'm going to use this. That's 7. The base of my exponential is going to be the 4th root of 19 sevenths raised to the x minus 3 power. There's my x1, 3, and my y1, 7. That is the exponential function I was looking for. A couple messages came in. Uh-oh. I think we could do another one. Let's try it. These things come in giant. I got to squeeze them down, or you won't be able to see my ink on my pen here. All right. A particle moves along the x-axis so that time t greater than or equals 0, its position is given by this. Determine all intervals when the acceleration is negative. So we're going to take the velocity, be the first derivative. How about 6t squared minus 12t minus 18? The acceleration, I'm going to go with 12t minus 12. I can't tell when my acceleration is negative or positive unless I know when it is 0. So I set it equal to 0. It looks like when t is equal to 1. It's 0 at 1. And of course, my domain starts at 0 and it goes to the right towards infinity. So I'm going to pick a test point of 1/2, and then I will pick a test point of 2. And my job is to find out what's the acceleration at those 2 points. When t is 1/2, when I come back up here, that would be 6 minus 12. Acceleration is negative. When it's 2, it's positive. Now, I kind of knew that because, I mean, this is the acceleration is a linear function, and it has a positive slope, 12t. So I know that this function was looking like this. Yeah, it's going to be negative over here. It's going to be positive over here. But anyways, that's it. So the answer is, when is it negative? It would be on the interval from 0 to 1 right here. That's where the acceleration is negative. That's how we do it. All right, back to some more problems. Let's go back up here. All right, let's look at this one. Question 1, the cost C in dollars to have medical records transcribed is a function of time, T in hours. A physician's group spends that many dollars to transcribe the physician's notes to an electronic document each month. What is the instantaneous rate of change when the transcriptionist has spent 100 hours transcribing the records? So, wow, calculator not allowed, it says. All right, so this is in dollars, and so it looks like we need to take the first derivative and evaluate it at 100 hours. So first derivative with respect to time would be 0.12 t squared minus 0.2 t plus 5.5 at 100 hours. Okay, man, oh man. So that would be c prime at 100. 0.12 times 10,000. That'd be right. Yeah. Okay. And then minus 0.2 times 100 plus 5.5. Okay. 0.12 times 10,000. Okay. So I'm going to move that decimal 4 places. 1, 2, 3, 4, 1,200. I think that's 1,200. That'd be right. 1, 2. I think it's 12,000. No, 1,200 would be right. And then minus 20 and then plus 5.5. That'd be 18. That'd be 1180. Yeah, looks like that would be it. 1185.5. Okay, students, nothing in the email, nothing more in the chat. Anything? What else you got? Taylor, anything else? All right, let's do a few more calc problems. Stand by. I'm going to do one more. How about that? Try and find a good one here. Maybe a free response. Let's see what we got down here. No, shoot. All right, here's one more. Those are calculator. We don't want to do that. All right, let's do this, and then we'll be done. Oh, why did I do? Click on that. Where was it? Oh, no. No. Yeah, that was it. All right, if a calculus book is dropped from a height of 100 feet, its height s at time t is given by the position function s of t, where s is measured in feet, t is in seconds. Find the average velocity over the time interval 1, 2. Okay, this is a good one. To find average velocity, what students will typically do is they will do an average rate of change calculation for the velocity. No, if I want average velocity, I need to do an average rate of change for the position function. Average rate of change over average velocity from 1 to 2 is going to be s of 2 minus s of 1 all over 2 minus 1. If you did v of 2 minus, if you said I'm going to take the derivative of position and get velocity, and you did v of 2 minus v of 1, that won't be average velocity. That's going to be the average acceleration, because think about what the units of measure are in this calculation. This is going to be in feet, and that's going to be in feet, and that's going to be in seconds. So that's going to give me feet per second average velocity. So be on the lookout for that. That's going to be a common mistake students make this first time around. So, but s of 2 looks like it's negative 64 plus 100, right? 4 times negative 64, minus s of 1 minus, and then s of 1 looks like it'd be negative 16 plus 100. What is that, 84? Negative 16 plus 100, and then all over 1. So this looks like it is 30, positive 32 minus 84, all over 1. And I believe that's negative 52, if I did that mental math right. So it'd be negative 52 feet per second would be my average rate of change. And there go the dogs. Somebody must have just got home. All right, students, I think that's going to do it for tonight. I didn't get to my plan on my top tips for raising your grade this semester, but maybe we'll do that next week. I wish you all a great week, and I hope to see more of you back next week, and I'll answer your questions to the best of my ability. Thank you for coming. Bye. See you next time.